Okay, ladies and gentlemen, moving on to the next example. Now, I know I didn't do everything in the last question. It asked for me to state the transformations of the function. Well, I did that. It asked me to sketch the graph for one cycle. I did that. And then it said determine the period, amplitude, phase shift, domain, range, and the equation of the horizontal axis. Well, yeah, okay. I didn't do that. This is the horizontal axis. We did figure that out. That was equal to 3. The period we should be able to figure out is 360 degrees. It's normally that for one wavelength of sine. So we're going from 30 up to 390 now. But so the difference between 30 degrees here and 390 degrees here is a difference of 390 minus 30, so 360. Well, you can't see what I'm doing. Ha ha! So the distance between 30 starting here and 390 ending here, the difference is 390 minus 30 is 360 degrees. So that's your period. The phase shift, well, the phase shift is just a fancy way of saying the horizontal shift. So the phase shift is 30 degrees to the right. That's what you would say. So 30 degrees to the right. The domain, well, the domain is really anything. It keeps going in both directions. So ideally, this would keep going and going. But because they asked for only one wavelength, you could argue that the domain is just the period. Well, no. You would say that the domain goes from 30 degrees to 390 degrees. Is that right? No, that's not right. I would say, you know what? I don't like that domain question. But the domain does go from 30 degrees to 390. What we would say is 30 degrees, 390 degrees, for lack of... Yeah, that's the best way to do it because that x value gets confusing. The range value, the range is going to go up to 5 and it's going to go down to 1. So your range value is going to have 1. So between 5 and 1. And your amplitude, we should know. This a value gives you your amplitude always, the absolute value of the a value. So it's going to be 2 units. And that just takes away any negatives that you might have had. So if you had a negative a here, the amplitude wouldn't be negative 2 units. The amplitude's still 2 units. And we can see that amplitude right here because we go up 2 units from the horizontal and we go down 2 units from the horizontal to its maximum and minimum respectively. Okay, so back to example 2. So example 2, let's see what we got going on here. We got y equals negative. So right off the bat, if I'm going to state what my transformations are here, I've got an a value of negative 1, which means the absolute value of a is going to equal 1 unit. So there's no vertical stretch here. There is a reflection. It's a reflection in the x-axis. Okay? And we can read right from here that my amplitude's now going to be 1. Okay, so what else we got going on here? We've got a h value. Another way of saying an h value is a phase shift. That's a really nice way of talking about it. So the phase shift is actually 60 degrees horizontally to the left. Careful with that. See that plus? That means that that phase shift, that means that that h value is negative 60 degrees. That's how the negative and negative make that positive. And you've got a vertical shift down 1 unit. And that's because you've got a k value of negative 1. Okay, so how would I graph this? Well, what I would do is I would say to myself, okay, I've got a reflection, I've got a shift horizontally, and I've got a shift vertically. Personally, I think I'm going to do this in 2 steps. So I'm going to first graph 30, 60, 90. 30, 60, 90, 30, 60, 90. Why do I keep doing that? 30, 60, 90, 30, 60, 90. And I got to be able to go this way. 30, 60, 90, 30, 60, 90. And I know that because I'm going to be moving horizontally to the left. So I'm just thinking a little bit ahead here. My amplitude's 1, and I'm going down 1. So it's going to be a pretty short graph. I'm going to make that 1. I'm going to make that -1. I'm going to make that 2. I'm going to make that -2. And I did that because I know that my amplitude is 1, but I also know that I'm going to be moving down 1. So I'm going to have to be able to get to -2. So my original function sine curve goes from here to here to here to here to here. And it looks like this. And you better get the shape right. And I'm going to be looking at the shape, and if it's too straight on the ends, if it's not concavity, if it's not concave, concave down here and concave up, if the concavity is not followed, that's going to lose your mark. So that's y equals sine x. That's not what they asked for. They asked for negative sine x plus 60 minus 1. So I can do this in 1 step. I can do this in 2 steps. I could do this in 3 steps. Let's do the reflection first. The reflection is going to do this. It's going to take this -1 and put it here. It's going to take this +1 and put it here. It's not going to change these guys. And that's going to be my reflection. So that's going to be y equals negative sine x. Again, that's not what they asked for. They want it to be moved horizontally to the left 60 degrees. So it's going to be 30, 60, and down 1. Not 1 hash mark, 1 unit. So 30, 60, down 1. This guy, 30, 60, down 1. 30, 60, 30, 60, down 1. 30, 60, down 1. 30, 60, down 1. Now I like to move the horizontal axis for the curve right away. I know that it's down 1, so it's going to go from y equals 0 to y equals -1. So I like to put that in to make sure that I got these 3 points along the proper horizontal axis. And I do, and it's going to look like this. So it's going to come down and up and up and down. Something seems a little off here. 30, 60, 30, 60, 30, 60. No, I'm good. All right. The other way to do this question, again, is with mapping notation. And you need to know both, because on a test or anything, we will ask you for the mapping notation. So in this case, the mapping notation is going to be x comma sine x. And to go over to here, to do this, to do all of these things to it, let's work through it. There's going to be a phase shift to the left, 60 degrees. So all the x values have to be moved to the left 60 degrees, and that's what does that. And then I've got a reflection, so all the y values have to be, all the positive ones have to be made negative, all the negative ones have to be made positive. So that's going to be negative sine x, and then they're all moved down 1. So if I take my 5 points, 0, 0, 91, 180, 0, 270, -1, 360, 0, that's going to go to -60, -1, 30. So sine x is 1, sine x is 1, -1, -2, 120, -1, 210, -1 times negative is going to be positive, so 0. And then finally 300 minus 1. Let's see if that works out to the points that we have. So this point here should be -30, -60, -1. It is. This point here should be 30, -2, 30, -1, -2. It is. This point here should be 120 minus 1, 90. 30 more is 120, -1. Yep. This point here is supposed to be 210, 0. So it's 180 plus 30 is 210, comma 0. And the last point here should be 300, negative 1, and it is. So they're both good methods. Be able to do both. Let's go on to example 3. I'm going to pause the video and we'll be right back.